So we're going to dive into the next lesson, and that lesson is scientific notation. So when I'm talking about scientific notation, the big piece that I need to understand is what's the point? So why am I using scientific notation? The reason behind it is because I want to make really, really big numbers or really, really small numbers into bite-sized chunks. So that mean the exact same thing. So for example, if I have 5 billion, right? That's going to take me a little bit of time to write all those zeros. All right. So when I'm dealing with scientific notation, I want to be able to write the exact same number, but write it in an efficient and quick manner. All right, this is going to come in handy, particularly in classes like chemistry, when you're dealing with really large numbers or really small numbers. So with scientific notation, what you want to do is you want to create a number between 1 and 10. So with 5 million, for example, the only place in which I can create a number between 1 and 10 would be to move the decimal over, which is right here, right? It's 5,000,000.0, to move it over enough places so it's a number between 1 and 10. So if I move it here, that's not a number between 1 and 10, not a number between 1 and 10, right? And now it's, instead of 5 billion, it's 5 million. All right, that's not, this is not, that's 500, that's 50. That is now a number between 1 and 10. That's saying 5.0. 5.0 or 5 times, now each time you move a decimal over, that's a power of 10, right? Because that's the ones place, the hundreds place, the ones place, the tens place, the hundred place, the thousands place. So each time it's multiplying by 10. So I moved over 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it over 9 times. So 5 times 10 to the power of 9 is another way to write 5 million. So every time I move over to the left, I'm increasing the scientific notation value, right? So if I have 53000, right, 53,000. Let's try that one. That would be, I need to get a number between 1 and 10. Well, I would move it over 1, 2, 3, 1. That's 4. So it'll be 5.3 times 10 to the 4th power. Okay. Now, there are also times in which I'm going to have to deal with going like when I already have a decimal that's in a different spot. So for example, if I have 507.2, 507.2. Well, this is currently in standard form because it's not a number between 1 and 10. All right. And what I would need to do is I would need to move the decimal over to make sure that this becomes a number between 1 and 10. So let's think about how I could make that happen. So what I would do is I would say, to get this to between 1 and 10, I would go 1, 2, and that would be 5.072 times 10 to the third, 10 to the third power. Okay. Oh, I made a mistake, didn't I? It's not 10 to the third power. It's, I only moved twice. It's 5.072 times 10 to the second power, right? I actually just count the number of places that I moved the decimal. So be very, very careful with that. Now, sometimes people get confused on problems that are like this. 5, or I keep using the number 5. 432 times 10 to the 4th power. Is this in scientific notation? If I have 432 times 10 to the 4th power, is that in scientific notation? The answer is no. This is not in scientific notation. What I would do to make this in scientific notation is I have to have a number between 1 and 10. Currently, I have the number 432, so that's not a number between 1 and 10. So what I would do is I put the decimal there, and let's think, would I move the decimal to the right or to the left? Well, the only way I can get between 1 and 10 would be to move this decimal to the left 2 times. 1, 2. And that would be 4.32. Now, anytime I move the decimal to the left, my number, the exponent that it's going to get raised to, is going to increase. So it was at 4. I move it to the left once, so that means it's going to be at 5. Move it to the left twice, that's going to be 6. 4.32 times 10 to the 6th power. All right. Now, scientific notation can also go from big to small. Or sorry, I can also be dealing with really small numbers, right? So if I have 0.00045, I can write this in scientific notation, all right? I just want to have a number, once again, between 1 and 10. Now, where would this decimal here have to be to make sure I had a number between 1 and 10? Well, I would have to move it to the right or to the left. Well, in this case, I would have to move it to the right. So I'd have to move it 1, 2, 3, 4. I'd move it 4 to the left, and you guessed it, it would be 4.5 times 10 to the power of, well, this would be negative 4, right? Because when I moved to the left, it was going up. Anytime I move to the right, it's going to be going down. So next, another problem that would be similar to this would be 0.36. Sorry, that would not work. 0.0003624. Okay, and I wanted to give this example because I want to show that you can have a whole lot of numbers after the decimal place. The only thing that you can't have, or the only thing that you can't take, like, you have to be very careful about your zeros in these situations. All right, so if I have 0.0003624, I'd move the decimal over multiple places. In this case, it would be 4 times once again. 1, 2, 3, 4. And it would be 3.624 times 10 to the negative 4th power. So in this case, what I would do is I would have my final answer, but I would need to make sure that I would write the 0.624. I can't just leave it as 3.0, right? I have to write out the 3.624. I have to have all those numbers. For another problem would be going, if I have 0.0052 times 10 to the power of 3. Suppose I have 10 to the power, right, of 3. This is not in scientific notation currently. All right, so it's not in scientific notation. So what I would do, and the reason why it's not in scientific notation is because the 0.0052 is not, it's not a number between 1 and 10. That is very, very important for scientific notation. It's also not in standard notation, right? Because standard notation would just be like if it was just 0.0052 with no 10 to the power of anything, it would just be 0.0052. So it's neither scientific nor standard. It's very close to scientific, but how would I move this to be scientific notation? I'd have to move the decimal to the right now. 1, 2, 3 times. So this would be 5.2. Now I moved it to the right 3 times. So that would, anytime I move the decimal to the right, as you can see, it goes downwards, right? It's negative. So I minus 1, minus 1, minus 1. And now I'm at times 10 to the 0 power. Now, if you remember, anytime you have 10 to the 0 power, or any number to the power of 0, 5 to the power of 0, 10 to the power of 0, 1 to the power of 0, your answer is always going to be 1. So 5.2 times 10 to the power of 0, if you want to simplify it, it would just be 5.2. All right, so that would be how you would solve some of the scientific notation problems with your most basic level of scientific notation problem. But sometimes you have to go from scientific notation, all right, so from scientific notation to standard notation. So if you were to do that, you would have to do, if you were to go from scientific to standard, right? If they said do 5.2 times 10 to the fourth in standard notation, so that means just write it without the 10 to the power of something, right? So 5.2. Now, remember, this, anytime I go to the left, the exponent increases. Anytime I go to the right, the exponent will decrease. My goal, if I wanted to get it in the standard notation, is to make this 10 to the power of 0. Why? Because 10 to the power of 0 is equal to 1, like we did in the last problem. So to make this a problem in which I'm writing in standard notation, I would want to go to the right, because I want to get the 10 to the fourth as small as possible. If I go to the right, it will get to 0. So if I go 5.2, right, and I go to the right one, this is at 10 to the fourth. Now this is at 10 to the third. That's I want to move it over 4 times. 1, 2, 3, 4. That's 10 to the second. That's 10 to the first. That's 10 to the 0. Okay, so that's, and the decimal now goes there. So it's no longer here. I get rid of that. It's going to be 52,000. All right, so let's try one in reverse. If I have 5.8 times 10 to the negative 2, now what I would want to do is I want to, again, to make this 10 to the power of 0, right? So anytime I go to the right, the exponent is going to get smaller. So if I went to the right, it would be negative 3. If I went to the left, the exponent would get bigger. I want to get it to be 10 to the power of 0. So I would need to move it over twice. So 5.8, and I move it over 1, 2. And that's going to be, because that would be 10 to the power of negative 1, 10 to the power of 0. This is a -1. And so I'd have 0.058. So that would be the problem in standard notation. Okay? So we've gone over the basics of scientific and standard notation. Let's, you can obviously try these two problems on your own. You can pause the video at any point to try any problem. But if it asks you to write the following in scientific notation, 20.5 times 10 to the 8th. Well, this is currently in neither scientific nor standard notation. So how I would do that is I would make sure I get a number between 1 and 10. To get a number between 1 and 10, I move the decimal to the left. So that would be 2.05, and I'd be at times 10 to the power of, well, I moved it one place. Anytime I go to the left, that increases the value, so that's going to be 10 to the power of 9. So let's try the next one, which is 0.0575 times 10 to the 7th, which is going to be moved to the left twice, right? And that's going to be 7.5. Now, if it's moved to the left, what do I need to do? Do I go up or do I go down in terms of the exponent? If I move, it's going to the right. It's not going to the left. So if I'm going to the right twice, I am going to do times 10 to the power of, well, this is going to go down. So this is going to be 10 to the power of 5. All right. The next type of problem is going to be multiplication in scientific notation. These are not too bad. Multiplication and division of scientific notation is actually easier than addition and subtraction. So we're actually just likely going to cover multiplication and division today. We might dive into a little bit of addition and subtraction, but we'll see. In terms of multiplication, if I have 5 times 10 to the 3rd times 3 times 10 to the 5th, what I would do is I would treat each entity separately and combine. This is not officially combining like terms, but I would do everything that looks alike together. So I know that the 10 to the 3rd and the 10 to the 5th, those are very similar. So I'm going to combine those, and the 5 and the 3 are similar. Let's do this in red. The 5 and the 3 are similar. So let's combine those. So if I have that, I'm going to have 5 times 3, and then I'm going to do 10 to the 3rd times 10 to the 5th. Okay? That's going to do, and remember, you can have a calculator for these, but this one is particularly easy, so you don't actually need a calculator, because 5 times 3, is 15. Now, the other part is 10 to the 3rd times 10 to the 5th. Now, if you watched the video yesterday, you would know your multiplication of exponents rules. Now, this is a base, and this is an exponent. When I have a base and an exponent and no coefficient, I know that bases are going to always stay the same. So the base is going to stay the same. The exponent is going to follow the rule. And the rule for multiplication of exponents is you actually add them. So 10 to the 3rd times 10 to the 5th is going to give you 10 to the 8th. So what would I do with this information is I would go, instead of, most people would say, well, my answer is just 15 times 10 to the 8th. Unfortunately, as we learned in the previous slides, I can't just leave it as 15 times 10 to the 8th because 15 is not a number between 1 and 10. So what do you think I'm going to have to do to solve the last step of this problem? Feel free once again to pause the video. All right, so if I want to get a number between 1 and 10, I will have to move the decimal one place to the left, and that's going to give me 1.5 times 10 to the, well, if I move it to the left, what's going to happen to this 8? It's no longer going to stay an 8. It will now become a 9. 1.5 times 10 to the power of 9. I can try one more quick multiplication one, and then I'll do a division one. Let's just take two numbers. 3.5 times 10 to the negative 5th and 4.8 times 10 to the 11th. Okay, actually let's do a negative number, make it a little bit harder. Negative 7th. Okay, now I'm going to pull up a calculator because I want to emphasize that you can use a calculator for these. All right, and what I want to do is I want to have everything together that I can. So if I have 3.5 and 4.8, I'm going to do 3.5 times 4.8 as one part. And then I'm going to do times 10 to the negative 5th, that's 10 to the negative 7th as the other part. Two parts of the problem. And then I'm going to get my calculator out, if I can pull it up. I'll do 3.5 times 4.8, and that's going to equal 16.8. That's 16.8 times, now 10 to the negative 5th times 10 to the negative 7th. Well, I'm going to add my negatives together, right? And I'm going to get 10 to the power of negative 12. Now, what I want to do here is make sure is my number here between 1 and 10 for it to be in scientific notation. Well, it is not. It's 16.8. The only way I can move this or make this a scientific notation problem is to move it one spot to the left, making it 1.68. Now I have to see what happens to this value if it's 1.68. If it's 1.68, it's going to be times 10 to the power of what? If I move it to the left once, anytime I move an exponent to the left, my exponent becomes greater. All right, so what's 1 greater than 10 to the negative 12th? That's 10 to the power of negative 11. So 1.68 times 10 to the power of negative 11, and that is done. All right. The next step is, and the last thing that I'm going to do today, is division of scientific notation. So division, once again, you can use a calculator, but this one is going to be relatively simple. Is I'm going to combine anything that's similar. It's not, I don't want to use the phrase combine like terms, but you're going to be working with the pieces that are similar. So the 3 and the 4, right? you're going to get 3/4, and you're going to get 10 to the 4th and 10 to the 8th. Or sorry, let me flip that. This is going to be 10 to the 8th, and this is going to be 10 to the 4th. So we have these two things. So this is now scientific notation has to be in a fraction. If I turn 3/4 into a fraction, you can use a calculator, but you shouldn't need to. That'd be 0.75. And then division of exponents is, if multiplication of exponents was add the exponent, what is going to be division of exponents? You said subtract, you are correct. That would be times 10 to the 4th power. 8 minus 4 equals 4. All right, 0.75 times 10 to the 4th. Now, the real question is, am I done? I look again and I see, is 0.75 times 10 to the 4th, is the 0.75 a number between 1 and 10? No. So what would I do? I would now move this one place to the right, 7.5. Now, anytime I move a decimal to the right, the exponent goes down. So that would be 10 to the 3rd power, right? So your final answer is 7.5 times 10 to the 3rd power. All right, I am going to call it there. Continue to work on your math packets. Let me know if you have any questions. Once again, I'll put my email here. For you guys. And that is it.